Hi students, today we are going to see how to solve problem in Otto cycle. Let us take a problem which has the data. The initial pressure P1 is zero point 0.1 megapascal, nothing but zero point 0.1 into 1000 kilopascal, which is equal to 100 kilopascal, and the initial temperature is 35 degrees Celsius. By adding 273, we get a 308 Kelvin, and we are also given the compression ratio as 8, and heat supplied during the cycle is 2100 kilojoules per kilogram. And for air, Cp, Cv, R values are constant. We know this. So we are asked to find the maximum pressure and maximum temperature during the cycle, efficiency of Otto cycle, and mean effective pressure in the cycle. Now the solution starts. So we know the equation of state PV is equal to mRT and P V by M is equal to RT. The total volume by mass is nothing but a specific volume. So we get PV is equal to RT. So from this we get V1 is equal, when we put this as P1 V1 is equal to RT1, V1 is nothing but RT1 by P1. So let us substitute the values. R 0.287 kilojoules per kilogram Kelvin, T1 is 308 Kelvin, and P1 is 100 kilopascal or 100 kilonewton per meter squared. So finally we get V1 is equal to 0.884 meter cube per kilogram. Now the compression ratio RC is nothing but V1 by V2, total cylinder volume by clearance volume. From this we can find out V2 is equal to V1 by RC, where V1 is 0.884, just now we found, and RC is 8, it is given in the problem. So we get V2 is equal to 0.11 meter cube per kilogram. So T2 by T1 is equal to V1 by V2 power gamma minus 1. So from this we can find out that T2 is equal to T1 into RC power gamma minus 1. So we know T1 is given as 308 and RC is 8. From this we can find out T2. So now we have come to know what is V1, V2 and T2. So to find P2, we are going to use the process 1 to 2. In this, the relationship between pressure and temperatures are P2 by P1 is equal to T2 by T1 power gamma by gamma minus 1. So we want to find P2. So P2 is equal to P1 into T2 by T1 power gamma by gamma minus 1. Now P1 value is 100, T2 is 707.5 and T1 is 306. Gamma value is 1.4 for air. So finally we get P2 is equal to 1837 kilonewton by meter square. We know during the process 2 to 3, volume is constant. So V2 is equal to V3. Already we found out V2. So V3 value also same as 0.11 meter cube per kilogram. The heat supplied is given in the problem, which is found by using the formula Cv into T3 minus T2. So we want to find out T3 using this expression. Therefore Qs by Cv is equal to T3 minus T2. Finally T3 is equal to Qs by Cv plus T2. So by substituting the values, Qs as 2100 and Cv as 0.718 and T2 as 707.5. So finally we get T3 is equal to 3632.3 Kelvin. And this Qs we have to take as a small Qs because it is a specific heat supplied. It is given as kilojoules per kilogram. So we are going to use symbol small Qs. So finally we got T3 is equal to 3632.3 Kelvin, and this is nothing but the maximum temperature during the cycle. Next we are going to consider the process 2 to 3, and we are going to use the equation of state because this process is constant volume process. So P3 V3 by T3 is equal to P2 V2 by T2, and since it is constant volume, V3 V2 gets cancelled. So P3 by T3 is equal to P2 by T2. So P3 is equal to P2 into T3 by T2. So we know all the values. We will substitute all the values and finally we get P3 as 9431.12 kilopascal. This is nothing but the maximum pressure during this cycle. We know V1 is equal to V4. So what are the value we... So V1 is equal to V4 is equal to 0.884 meter cube per kilogram. Because already we found V1, so that the same value we give for V4 also. When we consider the process 3 to 4, T4 by T3 is equal to V3 by V4 power gamma minus 1. So V3 is also equal to V2 and V4 is equal to V1. So we get V3 by V4 is nothing but V2 by V1. So finally, V2 by V1 is nothing but 1 by RC. So we get T4 is equal to T3 into 1 by RC power gamma minus 1. Let us substitute the value of T3 and RC value in this equation. We get T4 is equal to 1581.5 Kelvin. Now, between the pressure and temperature during the process 4 to 3 isentropic expansion process, the relation is P4 by P3 is equal to T4 by T3 power gamma by gamma minus 1. From this we can find out the value of P4. So P4 is equal to P3 into T4 by T3 power gamma minus 1 gamma by gamma minus 1. So when we substitute all the values, we get P4 is equal to 513.33 kilopascal. So finally we get the efficiency of Otto cycle is equal to 1 minus 1 by RC power gamma minus 1. When we substitute the value of RC, we get the efficiency as 56.47%. Finally, we have to find out the mean effective pressure. So we know mean effective pressure is the ratio between work done and stroke volume, where work done is heat supplied minus heat rejected and stroke volume is V1 minus V2. So we know the heat supplied is 2100 kilojoules per kilogram. It is given in the problem, and heat rejected is equal to Cv into T4 minus T1. We know all the values, and finally we get QR is equal to 914 kilojoules per kilogram. So by substituting the values, we get W is equal to 1180 kilojoules per kilogram and Vs is equal to 0.774 meter cube per kilogram, and finally we get PM is equal to W by Vs. By substituting all the values, we get PM is equal to 1532.23 kilonewton by meter squared. So in this problem, we found out the maximum pressure during the cycle as 9431.12 kilopascal, maximum temperature as 1581.05 Kelvin, efficiency of the Otto cycle as 56.47%, and finally the mean effective pressure as 1532.23 kilopascal. Thank you.